Okay, so our first problem, listen up, our first problem is a piecewise function. We're asked to make decisions on it. So it says, let f be a function given above. Which of the following is true about f? The function exists. Does the left-hand limit equal the right-hand limit? So we're looking at the left-hand limit. Since this is a polynomial, let's just plug 3 in. We get 8. And if we plug 3 in here, we get 8. So that's yes. Because the left-hand limit equals the right-hand limit. Okay, now the next one is f continuous at x equals 3. So to determine if it's continuous, we ask, is the left-hand limit equal to the right-hand limit equal to the function? Or does the limit equal the function? The answer is yes. Yes, because the f of 3 equals the limit as x approaches 3 of f of x. Okay, so that's that one. Third, is f differentiable at f of 3? To do that, we have to determine, does the slope from the left equal the slope coming from the right? So we're looking at m. M here is equal to 1 at 3, because we're taking the derivative. And here, m is equal to 3 at 3. So this would be no, because f prime at 3 don't equal each other. So therefore we're saying 1 and 2. So answer D is what I would go with. Okay, is everybody clear on that? Okay, let's go to the next problem. Okay, the next problem. Okay, I want you to be very, very aware of this problem here, like this one. Tomorrow, I can almost guarantee you're going to get a number of problems like this. Okay, it's just like an AP. You're doing like an AP test right now of chapters 1 and 2. The strategy here is, remember your rule that the sine of u over u as the limit as u goes to 0 is 1. Okay, now I don't have the sine of u over u. I have the sine cubed of the quantity 3x. So my u in this case is 3x, and it's cubed. So I'm pretending that I have a sine of 3x times a sine of 3x times a sine of 3x. And it's all over. I got 1x here, I got 1x here, I got 1x here. But I don't have 3x over 3x. So I need to put a 3 here. But to do that, I got to put a 3 upstairs. And you see the strategy. I put a 3 here, I get a 3 here, and then I get a 3 here, I get a 3 here. So what I end up with a 9 on top, that's unaccounted for. I have all these nice pairs of sine of u over u. And my u here is 3x. So the answer's got to be 9. So there it is. Because the limit as x goes to 0 of... Oh, sorry, 27. 27. Thank you. It's 3 times 3 times 3. How did I get 3 times 3 times 3 to be 9, not 27? Because I just was not thinking. Okay, so I would have got that one wrong. But tomorrow, we are going to get them all right. Okay, number 1b. Okay, now this is a hidden one now. This says x times the secant times the cotangent. So the strategy here is you want to go ahead and write them in terms of sines and cosines. So this is going to be 1 over cosine of x, and this is going to be cosine of x over sine of x. Okay, now you notice that your cosines reduce to 1. And what's left then is an x over a sine x. Well, that's the same type of situation, because we know the limit of that is going to be just 1 as x goes to 0. Don't get fooled. If this x says x to infinity, that's not the same thing. It's got to be going to 0. Make sure you always check on that. So I'm going to go with B, 1. Okay, next one. Now, the idea here, as many as these we get through today, our goal is to get through as many as we can. You want to redo these for speed tonight. Because you're going to need to do, the problems tomorrow you're going to have is a 45 dead on time quiz, because it's going to be truncated to 45 minutes. I think you'll get a little over I think there's 22 problems. You get the idea, you'll have enough time. You'll get 2 minutes a problem. So our goal here is to do this in 2 minutes or less, every problem, on average. So we're taking a limit as x is equal to a. So what we need to do now is we need to go ahead and break this up and say this is x minus a over x minus a times a binomial. Okay, so the binomial is one that I always forget. But I always know the first term is going to be x squared, and the last term is plus a squared. So I need to find out what this middle term is. I think it's plus ax. I think so. So what I'm going to do is multiply out, that FOIL's right. There's a negative ax squared, and here is a negative ax squared. That's right. So now all I got to do is cancel these two and reduce them out, and then I plug in a for the x's. So I get 1 over a squared plus a times x, which is a squared, plus another a squared. So it's 3a squareds downstairs. There it is. So answer is C. Okay, there's my answer, C. Okay, next. And so it's just arithmetic. Okay, next one. Okay, we're doing a limit of of just whatever this is. So I'm going to plug and chug. I'm going to say 3x squared plus 1 minus f of 0 is just 1 over x squared. So this is going to be 3x squared over x squared. And this is kind of what your work's going to look like tomorrow. And that's fine. These are multiple choice questions. Nobody's going to grade these. So I got 3 for an answer, and that's good. So remember, I'm not going to come grade these tomorrow. You follow me? I'm not going to make you put equal signs everywhere. This is where you finally get to say, Mr. Huss, I get to do what I want to do on these. That's fine. Okay, so let's do the next one. We're 7 minutes. Okay, we're 7 minutes into the recording. Okay, so we're going okay. What's the deal here? What's the derivative at 4? What's this graph look like? It's an absolute value shifted up like this. Okay, it's shifted up. What's the derivative at 4? I don't think it exists because it's a vertex. So if you know how to graph it, you'll do that. It's a vertex. No derivative. Non-exist. Next one, bless you. Okay, now, problem 3. It says, which of the following are true? Piecewise functions. Okay, this is the left-hand limit. The left-hand limit. So the left-hand limit we would get from this one. So the left-hand limit at 2 is 0. So the left-hand limit is equal to 0. This is not true. Left-hand limit. Now, this one's the right-hand limit. So the right-hand limit, I'm going to get this one, the right-hand limit. So I'm going to plug 2 into this one, and I get 4 plus 2 is 6. That one is okay. What about, it says the limit of f of x. Does it equal 6? No. Why? Because the left-hand limit? No. That's no. No. Because? What's that? Who asked question? Number 1? Okay, if I plug in 2. Oh, you're right. You're right. I'm sorry. Arithmetic mistake. Correct. So if I plug in 2 from the left, I get 2 minus 2 squared, which is negative 2. I'm sorry. That's true too. Good job. So number 6. Does the left-hand limit equal the right-hand limit? No. No. This is the left-hand limit. Left-hand limit is equal to negative 2. The right-hand limit is equal to 6, but the left-hand limit does not equal the right-hand limit, so the limit is not 6 at there. So 1 and 2 are true only. D. Next problem. Okay, number 4. Which of the following is true about this or false? We're looking for a false. Okay, we're looking at limits. What do we do at limits? We factor out and we reduce, right? So I'm going to make this x times x plus 5 over x, and then I see it's x squared minus 25. So it's x plus 5 times x minus 5. Okay. So now when I'm doing my limits, I'm really going to look at 1 over x minus 5. That's really what I want to look at. So from the left, okay, at 0, when x goes to 0, what is this function? Put 0 in here, what? Negative 1/5? Does everybody agree? That's false. This is false. It doesn't equal 0. It equals negative 1/5. Okay, as you go to negative 5, if I put negative 5 in for x, it's negative 1 over 10, right? That's true. Okay, third one. As you go to 5, is f of x non-existent? Wait a second. The left-hand limit is undefined, right? Okay, because now at 5, this is a DNE. Does not exist. So that's true. So I would go at number 1 only. Number 1 only. Okay, next one. We're looking at the limit of going to 0 again. Okay, so let's factor it out. I got an x squared here. I got 7x cubed minus 2. Oh, an x cubed. X cubed. X cubed. Okay, 7x squared minus 2. Then downstairs, I get an x cubed again. And I get left with 3x squared plus 10. Okay. What's it want me to do? At 0. So this is going to get rid of that. So do you see how easy I could put 0 in? It's going to be negative 2 over 10, negative 1/5. Okay, because I lose everything. Okay, next problem. Number 6. Okay, now we have the limit of two polynomials as they go to infinity. I could do all that work, but what do? I look for the highest degree, and I look at the ratio. They match up. One of the rules from pre-calc, I'm just going to go with A. That's it. I'm done. Next problem. Okay, next one, number 7. Now we're finding a derivative at negative 1. Derivative. Are there any questions of why I did that one so fast? You remember that's memorization of pre-calc, right? I could divide everything by 1 over x to the 5th and then let the limits of 1 over like x to the 5th go to 0. That would be the calculus way of doing it. Okay, so number 7. Okay, let's take the derivatives individually. We're going to put negative 1 in the end. So I'm going to jupe everything. Watch what I'm going to do. This first one is negative 2 over jupe cubed. Then the next one is minus negative 1 over jupe squared. Then I've got plus 3 jupe squared. Okay, so if I do it like that, instead of just putting the x there, I put a jupe. Now I put my negative 1 in. Negative 1, negative 1. This first term is going to be negative 2 over negative 1 because it's an odd power. It's 2 minus. This is going to be negative 1 over positive 1. Negative 1. This is negative 1 squared times 3. 3. 5, 6. I got an answer 6. E as in Edward. Okay, we're done. Okay. Now, the key there was what? Doing the jupes, right? Instead of an x, it'll save you a step. Okay, let's move on. We're on problem what? 8? 8 times 2 is 16 minutes. We've done those extra problems like 1A, 1B, 1C and that. And we're at 13 minutes and 48 seconds. You see how it's very doable at a pace of 2 minutes a problem? Don't ever think, but you got to work at this pace, right? I'm going to publish this video tonight. And you're going to be able to see it. You're going to be able to go through it again. And I'm wasting a little bit of time. That's okay. Let's go on. Oh, this is easy, right? What do we? Jupe it? 5 halves. Jupe 3 halves, right? Because we're taking the power rule. Put a 4 in here. What's the square root of 4? 2. What's 2 cubed? 8. What's 5 halves times 8? Okay. Reduce it. 20. Answer E as in Edward. Okay, that's it. Next problem. Okay, normal line. The equation of a normal line. Could you please, Taylor, would you get that? The equation of a line normal. Remember normal? What do we remember? Inverse perpendicular slope, right? Inverse perpendicular slope. So if you're given a slope of 3, the normal slope is negative 1/3. Okay, so let's do it. We're going to go at the point 1. So what we want to do is the equation of the line. Let's plug 1 in first. So the point is going to be 1 something. So y at 1 is equal to 1 cubed, which is 1, minus 3 times 1, which is minus 3, minus 7 plus 1. So the y coordinate is going to be 2 minus 10, which is going to be minus 8. So the point I'm dealing with is 1 minus 8. Now let's take the derivative and find y prime right here, one of these, right there, right there. Okay, so y prime at 1. Let's just joop it. 3 joop squared minus 6 joop minus 7. Notice I multiplied the 3 times the 2. Put in a 1. Put in a 1. Now, do your work. 3 times 1 is 3. Minus 6 minus 7 equals negative, what, 10? Slope's negative 10. Now do your line work. What are you looking for? What slope do you now need? That negative 10 gives you what? Negative 1, a positive 1/10. Your slope is positive 1/10. So now, here's what I'm going to do. Point slope form. Y equals 1/10 x minus 1 minus 8. Now we notice we have a standard form equation for a line for our answers. Multiply everything times 10. 10y is equal to x minus 1 minus 80. 10y is equal to x minus 81. Now you're looking at your answers. You notice that you got x is positive or negative. X is the front one. Y's are all whatever. So I'm just going to bring the x and say negative x plus 10y is equal to negative 81. Do I have an answer that looks like that? No, I don't. But I do have an answer. If I multiply everything by negative 1, I have x minus 10y is equal to a positive 81. I got that answer. So I'm going to select answer D. Okay, that took us about 2.5 minutes. Okay, so this will be on the web tonight, right? You can still do this. How are we doing on time? Got a lot of time, right? Okay, moving on. We're on problem, what, number 10 now, I think? We just did problem 9. Now we're on problem 10. Oh, sorry, folks. Went blue screen on you. Okay. Okay, we're still recording. Good. Product rule. Let's joop it. Okay, f prime of x equals 1 square root 3x minus 4 plus x times the derivative 1 over 2 square root 3x minus 4. Let's remember the baby of the chain rule, which is 3. Okay, now we got to make this look like. What's our common denominator? Do you see the common denominator is going to be 2 square root glob? Eliminate D, eliminate B, eliminate A. You see how I eliminated 3 answers right off the bat? If you have to guess tomorrow, guess from those 2. Let's finish the problem. Okay, what's the common denominator? It's going to be 2 square root 3x minus 4 times 3x minus 4 for the first term. And then the next term is going to be a plus 3x on top. Now, don't worry about the denominator. You've got it there. Don't write it. You don't need it. Okay, you know what it is. It's 2 times the square root. Let's work on the top. 2 times 3x minus 4 plus 3x. Just work on that. 6x minus 8 plus 3x. Work on that. 9x minus 8. Your numerator should be 9x minus 8. There it is. Your answer is C. Do you see your strategy of how to do that problem fast? You don't need to write everything. Find your common denominator. Then what? Work on the numerator, because you know that's not going to change. Then seek out your answer. Moving on. Problem 11. Product rule. Let's joop it. Okay. Derivative of x. 1. Cotangent. Cotangent. X. Next. Plus derivative of cotangent. What is cotangent? Opposite. Cosecant squared of x. Group. Plug in pi over 4. Cotangent of pi over 4. Where is it at? Right there. Slope of 1. Got it. 1 times 1 plus what? Pi over 4. Okay. What's the cosecant squared of x when it's pi over 4? It's up here, right? What is in it? 1 over square root of 2. squared, 1/2, negative 1/2. You with me? Okay, that's why we're taking our unit circle stuff. Okay. It's radical 2 over 2. But if you remember it as 1 over radical 2, it's easy to square. So that's where I get the 1/2 from right away instead of 2 over 4. So then I've got 1 minus pi over, let's see, pi minus 2 over 4. Okay, or better yet, it doesn't like that, does it? How about if I brought this one here, this 1/2? How about 1/2 plus? Wait, I'm getting screwed up with my signs. Cross it out. I'm at this stage and I'm right. So I've got 1 minus, what's that? 2 pi? No. Sorry, folks, I scribbled it out. I got to do it over again. Okay, this is how you do a multiple choice test. If you bag it, or you move on. Okay, ready. Cotangent of x, slope is 1. Then plus pi over 4 minus sine, and then the cosecant squared is going to be then 1/2. Okay, so now I then come up with what? Does this seem reasonable? Do you guys agree with me? Who doesn't agree with me? Ferris, what do you want to put? Cosecant of pi over 4. The cosecant is 1 over square root of 2, correct? Squared is 1/2, correct? It's 1 over radical 2, right? Oh, thank you. Yes, I kept doing this. I kept doing the sign. Correct. So this should be a 2 here. Okay, good. Thank you. So this is 1 minus pi over 2. We with it now? That's the one. Okay, 1 minus pi over 2. Took longer on that, but guess what? We put time in the bank, and we learned from what? My mistake of doing it. Good, for catching it. Thank you. Okay, what's this one? Is this function defined, is the slope defined at 2? What happens in positive numbers? Is the absolute value of x in the denominator the same as x? Do you understand? So graph this function. Okay, what happens to it? This here looks like this function with a -1. This is the function in quadrant 1. Do you agree? That's the function in quadrant 1. It looks just like a mirrored 1 over x. So let's just work with that one. What's the derivative of -1 over x? What's the derivative? Positive, because positive 2 over x squared. I'm going to put a 2 in here. I'm going to get 1/2. Do I have a positive 1/2? That's a 2 in there. Oh, this 2 shouldn't be. That's a 1. That's a 1. Do I have anything like a positive 1/4? I'm going to go with C. C. Okay, so what's the derivative of -1 over x? Positive 1 over x squared. Okay, next one, problem 13. Chain rule, twice. Let's do it. First derivative, y prime equals 3 opposite sine x over 3. Chain rule, 1/3. Simplify, 3 and 1/3 go bye-bye. We're left with the sine. Y prime is the sine of x over 3. Y double prime, okay? Derivative, opposite cosine x over 3. Chain rule, bring the 1/3 out. Okay, so we're looking for the opposite of cosine. Where do we see it? Not that one, not that one. How about this one? C. Okay, we got that one, right? Got it? Okay, good. Problem 14. What are we doing there? What's that one? Quotient rule. Quotient rule. Let's jupe it instead of doing the x because we're going to plug a number in. So, ready? F prime of jupe equals What's the derivative of x minus 1? 1. Joop the next one. Then minus Joop minus 2. Then what's the derivative of that? Downstairs. 1. All over Joop plus 2 quantity squared. Let's put the 2 in. 2 here, 2 here, 2 here. Okay, now you don't have to do them my Joop method. But if whatever works for you the best, do it. Now, I'm just simplifying. Upstairs we have 4 minus 0 over 4 squared. I'm going to go 1/4. B. Okay, next problem, 14. Oh, what do we have here? Power rule with a chain rule. Let's do it. Oh, we're going to do it at f of negative 1. So I'll do it the x style. F prime of x equals 2/3 gobbledygook, which I really don't need at first. It's just there, times the what? 1/3, negative 1/3 power, because we're subtracting 1 for the power rule. And then we got to do the chain rule. So that's going to be 3x squared plus 2x plus 2. No 0. Don't need to write that. So let's figure it out now. This is going to be 2/3. Negative 1 cubed is a negative 1. Negative 1 squared is a 1. Negative 1 times 2, negative 2, plus 1, all raised to the negative 1/3 power. Now, 3 times negative 1 squared is 3. 2 times negative 1 is negative 2, plus 2. Okay, now it's just arithmetic. Okay, so now what do we got? 2/3 times this group, that's a 0, that's a negative 1 to the negative 1/3. I think that's negative 1. This is 2/3. Then what do we have here? 3 minus 2 is 1, plus 2 is 3. 3 times 2/3 is 2. 2 times negative 1 is negative 2. I'm looking for a negative 2 answer. Negative 2. Okay. Problem 16. Tangent of 3x. Easy money. F prime equals the secant squared of that Joop, which is 3x. Then we have to do what? We have to take the derivative of the inside, which is 3. Okay, let's put pi over 9 in here now. So I won't make mistake again, Ferris. Okay, you got it? I won't make the secant again. Because when I got burned on it before, I'm not going to make the same mistake again. With that said, let's make sure I don't. Okay, what's the sine of pi over 3? It's square root 3 over 2. What's the secant? 3 over square root, or 2 over square root 3. So this is 2 over root 3 squared times 3. Does everybody buy that? I think that's it. Okay, so this is 4 over 3 times 3. I'm looking for a number 4. E. 16 is E. Number 17. Doesn't this take the wind out of you when you're... Did you, Jacob, you think I made a mistake? Well, I'm looking at canceling these 2 3s out. And I get 4. You see, I get 2 squared. I get radical 3 downstairs squared. And I had a 3 here. Does that make sense? Secant. Oh! I'm doing the sine again. The secant is the cosine. The secant. Oh, Ferris, I got burned again. What would I get for my unit circle quiz today? Oh, F. Give them an F. Okay, so therefore, the secant of pi over 3 is 2. 2 squared is 4. 4 times 3 is 12. Bag that answer. Go 12. That's why you guys are going to get a perfect score tomorrow, because you're that good. Okay, last year on this one, we had 5 perfect scores out of AB. Of course, we only had AB, so we had 5 perfect scores at AB. So out of you guys tomorrow, I want to see at least between AB and BC, 5 perfect scores to beat last year, okay? Can we set that as a goal to practice this tonight? Let's see what we can do. Some of you guys, I know you'll do it. Other you guys, you're going to do better than you would have done otherwise, right? And if you do good, it's a good first test score. Okay, let's do it. F prime at 9. Okay, I like to write this one 3x raised to the 1/3. So the derivative is 1/3 3x raised to the negative 2/3 times the baby, which is 3. Now I'm going to put 9 in there. So I'm going to go 1/3 of 27 raised to the negative 2/3 power times 3. This 3 will cancel with that 3. So I just got to evaluate. What is the cube root of 27, which is 3? Okay, what is 3 squared? It's 9 with a negative 1/9. I'm looking for 1/9. There, we got it. Okay. So evaluate that as quick as you can. You get 1/9. 18. 18. Oh, here's one thing to remember. Mr. Huss might make a mistake under time pressure, right? You guys might do that, right? Does it mean you have to have a perfect score to get a 5 on this exam in May? No. You could get a 70% and you're going to get a 5. You follow me? So what do you just have to do? Get them better than 70%, you'll be okay. So understand, you will make mistakes under time pressure. That's what this is about right now. How about product rule? No? How about chain rule? How about chain rule? I'm going to go with 2, the derivative. Okay, I won't even write the symbol. I'm taking the derivative. 2 sine of x cubed. That's the first step. Then this cosine of the x cubed. Then times the derivative of the baby, which is 3x squared. Now, what are we searching for? 6x squared. I don't have a 6x squared here. I don't have a 6x squared there. So where do I find a 6x squared with a sine cosine? There it is, A. You see how that problem was really quick and fast and easy? Okay, next one, 19. What's the value of the second derivative? At the point, 1 square root second. Okay, first derivative. What's the first derivative? 2x plus 2y, y prime, equals 0. I like to get rid of the 2's right now. So I'm going to say y prime equals what? Y prime is equal to negative x over y. Y double prime equals, now let's take the derivative. Negative 1 times y. Then minus a negative x times y prime over y squared. Okay, any questions, or did I do something wrong? Oh, the blue screen again. Sorry. For those of you that are watching this on tape, if it's somebody else, the blue screen means that the screensaver went on blue. Okay, so what's next? Well, we got to figure out what y prime is at 1 square root 35. Now, at this point, we're going to stop. Because y, well, let me show you how you would do it. You would take and put 1 here and put the square root of 35 there. Now, you could come back and then substitute that in for your y prime here. And you would plug these numbers all in. And you'd use your calculator in this problem, right? Now, we're not going to do it any farther because you won't have a calculator problem tomorrow. It'll be all strictly paper and pencil. But you understand now it's just substituting in. You would substitute this value in. So you might have a problem like this, but it'll be integers. It'll be something you can do. Okay, let's move to problem 20. Implicit differentiation again. Okay, just find the derivative. Ready? Okay, let's take the derivative of 2y, or of y squared. 2y, y prime, plus 2 times a joop. Derivative of x is 1. So 1 times y is just y. Plus, the derivative of the next thing would be x times y prime. Okay, that's done. Equals, what's the derivative of 12? 0. Now we got to isolate our variable. Okay, so now I'm going to bring 2y, y prime, plus 2x, y prime, and I'm going to put the 2y on the other side, negative 2y. Okay, notice everything's got a 2 in it, right? I'm going to get rid of that 2. So I don't make a mistake, I'm just going to write y plus x times y prime equals negative y. Can we see our answer from that one? You see your answer is going to be y prime equals negative y over y plus x. I wouldn't have written that on a multiple choice test. Once I could have done the moving it underneath and I saw that answer 1, or A, I mean, was it correct? I would have stayed there. Number 21. The slope of the line tangent to the curve at 2, 1 is. We just want the slope now. We don't need the equation. Let's take the derivative of this. 2y prime plus 2xy plus 1 to the first power times the baby, which is going to be now, the derivative of the baby is going to be y plus xy prime equals 0. Okay, now you should be able, after practicing taking the derivative of xy implicitly, you should be able to write it as y plus xy prime. Okay? If you practice that. Andrew, are you listening to me? I want you to take that one in your head. The implicit differentiation of xy is what? Y plus xy prime. Do that enough times and you'll remember it. But you'll make less mistakes on it. Okay, now we're taking the slope of the tangent line. I'm solving for y prime. I'm going to put in my numbers here. 2y prime, because I put in 1 for y, plus 2. X times y is 2 plus 1 times, then y is 1 plus x is 2 times y prime equals 0. Okay, now what I'm going to do next is I'm going to simplify my numbers. 2y prime plus 2 times 3 is 6. I'm taking a 6 and distributing it. 6 plus 12y prime equals 0. So I know that 13 y prime is equal to negative 6. Y prime is equal to negative 6 over 13. Now, I made a mistake somewhere, and that's nice, I did. Only because it's nice I did, because I like to see when I make mistakes and how I can go to try to find it. Okay, so if we have time, we're going to come back to problem 21. But at this point, maybe I know that this is a problem that I have more problems with, so I'm going to skip it for now. So let's come back later. Okay? Remember, we're watching our time, and we notice that we only have a few minutes left on the test, so we're doing it. Okay, I'm not saying, yeah, you have your answer, Todd, that's good, but I didn't, so I'm skipping it. Okay, equation for the line tangent to the graph at the point 17 is, we need to find the slope, then we need to plug and chug. So we're looking for our slope points at when x is 1. So let's find y prime at 1. Well, that's going to be equal to the derivative of the top, which is 3, times the bottom when I plug in 1, minus the top when I plug in 1, times the derivative of the bottom, which was 4. Then it's going to be the bottom when I plug in 1, all squared. Okay, so I have all my numbers now put together. And I know it's hard for you to read that on the board, but that's just all I did was the product rule, or quotient rule. So now I'm simplifying my numbers. 3 times 4 minus 3 is 1, minus 3 plus 4 is 7, times 4 is 28. So I'm going to put a 28 here. And then the downstairs is 1 because it's 4 minus 3 quantity squared. So I'm going to come up with this answer here is going to be a negative 25 for a slope. Okay, so that's the tangent line. So now I have to figure out what my y coordinate is. I got it, 1, 7. So I'm going to write point slope form, negative 25, x minus 1 plus 7. So now I just have to go ahead and distribute negative 25x plus 25 plus 7. Okay, so I see the numbers on the right, and I see my x's and y's are on the left. Since all my positives on the right, I'm going to keep my positive 32 on the right. From there, I could eliminate those two answers immediately. So I'm going to write now 25x plus y. So do I have a 25 plus x plus y? 25x plus y. There we have it. C. Okay. 23, 24. I'm looking at where I'm at. I'm making sure of my time. We're 40 minutes into it. You notice we've done well more than 20 problems, right? And we've taken time to explain it. We all would work faster if we were working individually. Okay, maybe not as fast, but we should see this as reasonable. The line normal to the curve at the point 0, 3. Find the slope at 0. Take the opposite reciprocal. So y prime at 0 is going to be now 1 over 2 square root 9 minus 0 times the derivative of the inside, which is negative 1. So the slope is going to be negative 1 over 2 square root 9, which is negative 1/6. So the reciprocal slope, negative reciprocal slope, is a positive 6. That's what we needed. It just has the slope of 6. That's all we needed was this to do problem 23. We'll never know what problem 23 is that quick unless we get to it, right? So if you don't watch your time, you might be giving up the easiest problem there is at the end of the test. 24. The graph of the function f is shown above. At which values is f continuous but not differentiable? Okay, is continuous. So it's continuous everywhere except here. But it's not differentiable here because we have a cusp there. Then it's not differentiable here because we have a cusp here. I'm going to say A and E only. What value of x is continuous but not differentiable? So is it continuous here and differentiable? Yes, not here. How about B? Did I forget B as I'm going through it? So I'm going to go A, B, and E. A, B, and E only. Okay. Now, when you find yourself an answer that you don't agree with, that's nice because it did that. Let's go back to 21 real quick. We have 2 minutes left on our thing, so we can probably eke this one out. It says the slope of the line tangent. I tend to forget what I did. I'll be with you in a second. I don't even look at it. I rework the problem. 2y prime plus 2xy plus 1 to the first power, y plus xy prime equals 0. Then I put in the numbers again. I try not to look at what I did. I want to put in 2 here, y prime plus, I know 2 times, I'll put a 2 here, and then I'm going to say 2 times 1 is 2 plus 1 is 3, times y, which is 1, plus 2y prime. Okay, and if I get the same answer, then I really know I'm doing something wrong all the time. Okay, and I can't figure out right now. Let's just see what we did now. So I've got 2y prime plus 6 plus 12y prime equals 0. So now I've got 14y prime is equal to negative 6. I will say y prime is equal to negative 3 over 7 now. So I'll see, do I have an answer to that? Yeah, I do. Okay, so I found my mistake. I could go back and find it. I don't care if I find it. I did match an answer up. We're done. It took us 43 minutes and 58 seconds.